Hey guys, it's Will from Tested. I'm at the Stanford Robot Block Party. I'm with Kyle Moore of the Stanford Robotics Club. You've built something pretty cool here, I think. Can you tell me a little bit about what you've done?
Certainly. So I've taken two little micro helicopters that you can buy on Amazon for $20, and I've reverse engineered the infrared protocol that they use for the transmitter so I can control it from my computer. And eventually I'm working on building a 3D laser scanner, sort of LiDAR setup, that is ground-based, that will map the room that the helicopters are in and figure out where the helicopter is. And then I'll use that information to make a autopilot system for the helicopter.
So you want to make the little helicopters that the guys fly around the mall autonomous?
That is correct, yes.
So okay, first thing you did was, it seems like, reverse engineered the IR signals that the remotes are sending to the helicopter. How'd you do that?
Well, it's actually been done a couple of times on the internet, so I mostly just did it to see if it was possible. So I started out I disassembled the remote control we have here, and then I hooked it up to a logic analyzer, which basically just measures the electronic pulses that come out. So I measured the pulses that it was sending to the LED, and I could graph that on my computer.
So in this case you used, it looks like an Arduino Mega or something like that, right?
Correct. So because I didn't actually have a logic analyzer and they're pretty expensive, I found a open source project on the internet that you can load onto your Arduino, and it turns it into a logic analyzer that is compatible with some open source software you can run on your computer.
That's fantastic. So then, okay, so now you know how the remote talks to the helicopter. What was next?
So the next part was to take that knowledge of how the protocol actually works and turn it into a program on this Arduino over here, and then hook it up to a couple of infrared LEDs to sort of make a Frankenstein remote control for the helicopter.
So you took something with really easy to use physical controls that anybody can pick up and then translate it to something that works on the computer, and I assume takes a fair amount of skill to use.
It's a lot harder now, yes. The first part was a major regression. Yes. Okay. At first I made it so you couldn't actually really control the helicopter at all. You could just kind of make it go up and down, and it was a big step backwards from the original remote control. So the next thing I did after that was I made it so I could control it from the accelerometer in my phone. So I wrote a little program on my computer and a little program on my phone, so I can turn my phone around like this, and the helicopter will follow my phone around and go up in the air and come back and lean forward and stuff like that.
So kind of like the paired AR drones or something like that, right?
Exactly, but without any of the complex hardware that the AR drones have on board.
So explain what LiDAR is. Assume I don't know what LiDAR is, and give me the quick explanation of how it works and what it does.
Okay, so LiDAR itself is like radar, but with laser beams, obviously. So in this particular thing right here, I'm using a line laser, which is just a laser that instead of making a dot, it produces a stripe of laser beam, and just a regular webcam with an infrared bandpass filter on it, so it can only see the laser beam. All the rest of the light gets blocked out. Okay. The goal was to make an inexpensive 3D LiDAR system out of off-the-shelf components that could still achieve a pretty reasonable scan rate. Because most of them were taking 15, 20 seconds to do a full 360-degree revolution. Actually, there weren't any that could do a full continuous scan and build like a constantly updating picture of the world. So there were a couple of challenges getting it so it could actually scan a full 360-degree picture, and then also making it so it could scan quickly but still have a reasonable resolution.
So how long have you been working on this, Kyle?
So I've been working on this for about a month now. I took a little bit of time off to take some finals and go on spring break and stuff, but it's been about a month so far.
Excellent. When do you think you'll have the whole thing working? What's your ETA?
So that's going to be tricky. I think I can get the LiDAR working in another week or two. I'm guessing it's about 85% done at the moment. Unfortunately, it doesn't look like anything. It's the 85% that's really unimpressive, but I think another week or two I'll be able to get that going, and then it's just sort of open-ended with how much time I want to put into the actual autonomous vehicle part of it, because I can spend a lot of time refining the algorithms for that and making it so it can do more and more interesting things.
Excellent. Well, thank you so much, Kyle.
Thank you.
We'll be back with more from the Stanford Robotics Block Party soon. Bye.